In this video, we'll be looking at another example of partial fraction decomposition. Again, remember the goal of this is to tear this fraction apart into its, in this case, 3 different terms. So the idea to start off is, can you factor that denominator? If you can factor the denominator, then hopefully the idea is to tear apart the whole fraction into however many factors in the denominator that actually exist. So again, for every factor, for every single factor in the denominator, there should be technically one term in the denominator. Now, we might change the rules in terms of how those denominators force the numerators to appear, but all in all, this is the idea and how we set things up. Now, for this one here, I'm going to have 2x minus 1 as one of the factors, and on top I will have the constant of a, because the bottom is a linear, the top can be a constant. If the bottom was a quadratic, the top could actually be a linear function. That thing throws a few wrenches into some problems, but for this example, we'll just go ahead and stick to the, hey, the linear denominator causes a constant numerator, and so on and so forth. So now I have 3 terms for this. And it's okay to have 3 terms. Just keep in mind that these are the 3 possible denominators I could have started with. So these are the 3 possible denominators that I'm going to have to end with. Now, when looking at this problem, the goal is to solve for A, B, and C. And we're going to treat this the exact same way we treated the last example. I'm going to multiply both sides by the common denominator. This original denominator in the original problem is the common denominator. So I will multiply this whole side by that denominator, canceling out that entire denominator, giving me this. I will multiply this whole side by that common denominator. Let's go through this step by step. If I multiply this thing right here by this thing down here, the 2x minus 1 will cancel out with the 2x minus 1, leaving me with a times the other 2 factors. I'm then going to have plus b. If I multiply this whole thing by those 3 factors, the x plus 2 is going to cancel, leaving me with the 2x minus 1 and the x minus 2. So I'm going to go ahead and write those 2 pieces down. Plus, and then I'm going to have a c. And on that c, I'm going to have the 2x minus 1 and the x plus 2. Now, you're looking at this problem, and I'm going to go ahead and reference, if you were to try and solve this using systems of equations, this would be more than just a nightmare. It would be such a heavy problem. It would require that you have, again, 3 equations of 3 unknowns. The x squared is one equation, the x is one equation, and the constant is one equation. And then solving that systems of equations would take you so much more work than the way that we're going to do this problem. Again, the idea is that this entire equation should be satisfied by every single x value, such that a, b, c are very clear numbers. So my first step is I'm going to go ahead and let x equal the first obvious number I can pick, negative 2. Okay, so the negative 2 will allow this term to become 0, this term won't matter, and this whole thing will become 0. That's also true for this term back here. That whole thing will become 0. So all I really have to do is, if I let x equal negative 2, I get 9 times 4 plus an 18 plus 6 equals to 0a plus 0b plus c times. It's 2 times the negative 2 is negative 4. Negative 4 minus 1 is negative 5. And then, I'm sorry, did I make a mistake here? Yeah, I did make a mistake here somewhere. This should be, oh, I made a terrible mistake here. This should be a minus sign. So this actually ends up going to 0. I'm glad that I checked my math on that and make sure that's correct. But the middle term should be b times, this is 2 times negative 2 is negative 4 minus 1 is negative 5. And then multiplied by negative 2 minus 2 is negative 4. So what I really have here is all this equals to, this again should not be a plus sign but a minus sign. And it should be b times negative 4 times negative 5. So it's b times 20 technically, equals to, and over on this side I'm going to have 9 and 9 is 18, 36. 36 plus 6 is going to be a 42, and 42 plus that is going to be simply 60. So b in this case is simply 3. So now I have my value for b. I can go ahead and pick a new x value to solve for a different variable. And I'm going to actually pick, again, a nice number. So let's let x equal 2 this time. And again, I'm plugging it all into this equation. I might have an issue keeping it all on the screen. I'm going to just zoom this back just a little bit. Hopefully that'll help. In this case now, when I plug in 2, I'm going to have, again, same thing is 1632. So So I have 32 plus, sorry, but this time it'll be minus the 9 times 2 is going to be minus 18, and plus the 6 equals. This whole term is going to go to 0. This whole term is going to now go to 0. And this term is the only one that's going to remain if x equals to 2. So plus c times, that's 4 minus 1 is 3, and then 4. So I'm going to have c is multiplied by 12. I'm going to move down now. C is multiplied by 12. And that's equal to, if I do, that's going to be negative 8 plus 6 is negative 12. Negative 12 is that's going to be a positive, looks like 20. Now, be warned, I might have made a math error in here somewhere, but I don't believe that I have. On the off chance that I have, again, it might be slightly off, but these values are still perfectly viable for potential solutions, assuming that all the steps have done right and all the arithmetic is done right. So again, let me double check one more time. I've got 9 plus 9 is 18. 18 times 2 is 36. And there, sure enough, I did make a mistake in my arithmetic. So let's try that one more time. If I do this is going to be 12, negative 12 there is going to be positive 24. And that's 2 arithmetic mistakes I've made in this video, but that's okay. Now I'm going to divide by 12 here, and that's going to give me c equals to 2. So now I have b and I have c. Now the third option is, well, let's let x equal another number. So I'm going to go back up here and I'm going to look at the options here. I've got x equals negative 2 for this one going to 0. I've got x equals 2 going to this one for 0. And in here I could pick a 1/2. I don't really feel like picking 1/2. I think 1/2 is going to cause me all sorts of a headache. I'm going to pick another number. I'm going to pick another number that's relatively nice. Now this is an option you have. What I'm going to do is I'm going to rewrite the entirety of the equation. 9x squared minus 9x plus 6 equals to a times x plus 2 and a times x minus 2 and then plus. But this is where I'm going to change things up. Instead of writing b, I'm going to write 3. Because this should work for every single x value. Regardless of what x value I pick, these equations should hold constant, meaning the b and the c, b should be 3 at all times, c should be 2 at all times. So I've rewritten this equation with b and c as what they really are. What I'm going to do now is pick a really nice number to work with in terms of x. It doesn't matter what number that I pick. Again, it doesn't matter. I pick these ones not arbitrarily, but very specifically to make things easier for me. So let's just do the same thing for this third one. I'm going to pick x equals 0 to make things easier for me. When x equals 0, this is 6, equals a times 2 times negative 2. And then this stuff over here is going to be plus 3 times a negative 1 times a negative 2, plus 2 times a negative 1 times a positive 2. And this arithmetic actually becomes really smooth and a lot less complicated. So now I have 6 equals to negative 4a. This one over here becomes plus, let's see if I can do this correctly this time, 6. And then this one becomes here minus 4. So this is going to be in total plus 2. Minus 4a equals to 6. And therefore, if I subtract the 2, I get 4 equals to negative 4a, and therefore my a is equal to negative 1. And now I have a complete conclusion of what my decomposition of this thing should be. It should be negative 1 over 2x minus 1 plus 3 over x plus 2 plus 2 over x minus 2. Now what I recommend when you get these problems and these solutions, anytime you get a negative, I would recommend putting that negative on top of that fraction. Again, you can put the subtraction sign again in front of it, but I would recommend making all these addition signs like our setup is consistently, and put the negative on top. So this is the actual thing that we're looking for in the very end. Again, it's not a, b, and c that I want. It's what is the partial fraction decomposition. So what does this thing break down into? It breaks down into this. Now if we did this correctly, that means that if I find a common denominator between these three fractions and add them back together, I should get back to this exact same thing, such that this is the common denominator and that top piece is the same thing that I have there. So again, this is the process to doing partial fraction decomposition. Depending on the examples you have, solving for a's, b's, and c's might be less or more complicated than other examples. In the next couple of videos, we'll be talking about the repeated factors as well as potentially more heavy, complicated factors. We did already talk briefly about the fact that if one of these were quadratic, then we'd have a linear piece on top. And we might see that in the next video.